Hey everybody, Mr. Troy here. Today we move one step further along on our journey towards mathematical excellence. Strap in, it's time for Math with Mr. Troy. Okay, this video is on combining functions, and today we are going to go through the 5 ways that you can combine functions. 4 of them are going to be relatively simple, and the 5th one is a bit of a challenge. In this video, we are going to focus on the nuts and bolts of how to add, subtract, multiply, divide, and compose functions. And then we will spend some time later talking about how to find the domain. So the first thing that you need to know is that these two notations mean the same thing. So if you ever see f plus g of x, that means the same thing as take f of x and add g of x. If you ever see f minus g of x, that's the same thing as subtracting g of x from f of x. So this, or this, or this is going to represent some new function, and x is going to represent its input. And we're going to see that that's the same thing as multiplying f by g with their inputs. So composition is a little bit tougher. You are going to read this as f of g of x. Okay, so 30-second crash course on what a function is. There is a function named f that if it takes its input x, it uses the rule 2x plus 1 to make an output f of x. So x is the input, and f of x is the output, and 2x plus 1 is the rule. So f's job is to take an input, multiply by 2, and add 1. Similarly, this is a function named g that takes x as its input, and the rule to get to the output is to square the input, add double the input, and then add 1. So let's start with this on the left side. F of 2 would be f with 2 plugged in, so 2 times 2 plus 1, that's 5. And g of 2 would be 2 squared plus 2 times 2 plus 1, which I think is 9. So f plus g of x means f of x plus g of x. And the way that you can find that is by adding their rules. So f plus g of x would be x squared plus 4x plus 2. F plus g of 2 would be taking 2 and plugging it into this function we just found. So to take 2 and plug it into that function would be 4 plus 8 plus 2, which is 14. So 2 squared plus 4 times 2 plus 2 is 14. And what you'll find is that that is the same thing as if you would have just done f of 2 plus g of 2. Okay, so let's move over to subtraction. Subtraction would be g of x minus f of x. Substitute in the rule or the formula or the right side of the equation. So x squared plus 2x plus 1. Now, the tricky thing for functions is this says subtract f of x, which means subtract all of f of x. So that would give us x squared. So if we plug in 2 to that, we just get 4, which is the exact same thing as g of 2 minus f of 2 from here. So finding the formula and then plugging in a number is the same thing as plugging in the number for each and then doing the math. Okay, pause, rewind, watch that again, see if you have any questions. Okay, we're back. So what's interesting about this is that you don't just have to use numbers that evaluate out simply. You can also plug in kind of some more out there inputs. So for example, f of 3z would be 2 times 3z, that's 6z, plus 1. So 2 times the input plus 1. G of 3z would be the input squared. That goes in parentheses because you're squaring all of it, plus 2 times the input plus 1. And that, as you can kind of see the similarity between the two functions, is 9z squared plus 6z plus 1. So if I take 3z and I plug it into f plus g, I should hopefully get the same thing. So let's see. If I plug in to instead this function, here I'll hit it with the highlighter so you can see what I'm talking about. So I'm going to plug 3z into f plus g, this function I already found. So I'm going to use 3z as my input for that. So 3z squared plus 4 times 3z plus 2, that's 9z squared plus 12z plus 2. And you'll notice that's the same thing that I get if I add f of 3z and I add g of 3z. So do that same thing now on your own with g minus f of 3z, just to verify that those work the same way. Okay, now we're going to try the same thing with multiplication. So, and division, of course. Let's copy those values over from the previous page. Voila, movie magic. Okay, so remember, f times g of x means f of x times g of x. So 2x plus 1 times x squared plus 2x plus 1. But what you have to remember are the grouping symbols. So you need to remember that that's in parentheses and that you kind of have to do this expanded FOIL, the binomial times a trinomial stuff, to get your formula. So our formula here should be, you know what, I'm going to pause the video and do it so you don't get bored. Okay, I believe it is 2x cubed plus 5x squared plus 4x plus 1. And if it's not, we should be able to tell when we do our plugging in later. So remember, f times g of 2 means take f times g and plug in 2 as your input. So that's going to be 2 times 2 cubed, which is 8, plus 5 times 2 squared, which is 4, plus 4 times 2, plus 1. So that's 16 plus 20 plus 8 plus 1, which is 45, which is 5 times 9. So a thing to think about when you're doing these type of problems is what's easier, figuring out f of 2 and g of 2 and then multiplying those, or figuring out f times g of x and then plugging in 2. In this case, it's definitely just the f of 2, g of 2 part. Okay, so the last one we need to take a look at is division, and this one's going to be the hardest. So the division here is going to be x squared plus 2x plus 1 over 2x plus 1. Okay. Now the question is, what happens if I plug in 3z? So if I plug in 3z, I'm going to get 9z squared plus 6z plus 1 over 6z plus 1. You can see that that is g divided by f, but as of right now in our Algebra 2 journey, we really don't have many more skills on what to do with that. So here are two for you to try, and we'll talk about them in class. Don't worry about the domain yet. That's what we're going to talk about in person. So pause the video, give these a try, see if you've got any idea what's going on. They're simpler than they look, perhaps. All right, and the last thing is the composition. Again, we will do the domain in class, so don't worry about that now. So what f of g of x, or you'll hear some people say f compose g of x. What that means is take f and use as your input g of x. So I'm going to try and color code here to make that easier for you. So what it's saying is evaluate the function f, but instead of using x as your input, use all of g of x as your input. So use all of 4 minus x squared as your input. So you're replacing g of x with the rule or the formula. And then remember, what this means is do the function f, but use 4 minus x squared as your input. So this is where it's really important to remember that a function's job is to, well, in this case, it's to take an input and add 2. So f of Patrick would be Patrick plus 2. I guess I have 2 dogs. Maybe that's what it means. Okay, so f of 4 minus x squared means 4 minus x squared plus 2. So that would be negative x squared plus 6. Okay, now g of f of x would be g of f of x. I think color coding this makes it easier. I hope you feel the same way. So that would be g of x plus 2. Okay, so that means take x plus 2 as your input and apply g to it. So the function g is take your input, square it, and then subtract that from 4. So the way that it would look would be like this. 4 minus input squared. And here our input is x plus 2. So remember that you have to FOIL that out. So that's 4 minus x squared plus 4x plus 4, which gives me negative x squared minus 4x. For g of f of 2, of negative 2 rather. So this means g of f of negative 2. You have two options. You can plug it into this formula that we already found, or you can work from the inside out. Here's what I mean by working from the inside out, which is actually what you're going to do more often. Okay, so working from the inside out means finding f of negative 2. So f of negative 2 is 0. Then doing g of 0, which is 4. That's the exact same thing that you would get if you plugged into this function. You would also get 4, and that's kind of the point of all of this. We are going to start with these problems. So you can, if you want to get a head start, you can go ahead and do those problems. And then our important conversation is going to be about the domain. All right, hope you enjoyed. Have a good one.